So good afternoon. So let us start JEE Mains April 7th, second session, 3 to 6 o'clock. Question number 51, hydrolysis of oligopeptides. Oligopeptides, first what is meaning of oligopeptides? Oligopeptides means generally 2 to 20 number of amino acids made up of 2 to 20 number of amino acids. More than 20 take polypeptides. Gives us a few number of amino acids, means up 20. Okay, a few means oligo means few, while the protein gives rise to large number of beta amino acids, but there is no beta, all of them are alpha only, no beta. Any protein, maybe small protein or large protein, any protein made up of alpha amino acids and belongs to L series only. Alpha amino acids and belongs to L series. That's why one false. Natural proteins are denatured by acids which convert water soluble form of fibrous protein to their water soluble form of fibrous protein. Fibrous proteins are water insoluble. So, this statement wrong. Water insoluble, fibrous proteins are insoluble. Fibers. But what is meaning denaturation means breaking of structure of secondary and tertiary. Loss of secondary tertiary structure is called denaturation of proteins. So, this is not correct. The acid may undergo hydrolysis of polypeptides into small protein parts. So that is called breaking of the polypeptides into small protein part, but not water soluble form of fibrous protein. It is wrong statement. So that is why both are wrong statement. Both are wrong statement means option 3. Next, mixture of 1 gram each of chlorobenzene, aniline and benzoic acid dissolved in 50 ml ethyl acetate. That means organic compound solved in organic solvents. 1 gram each of chlorobenzene plus aniline plus benzoic acid. Okay. Dissolved in 50 ml ethyl acetate solution, solvent. Okay, so like dissolves like soluble. Next, and placed in a separating funnel 5 molar NaOH 30 ml. Now it is taken into a separating funnel having 5 molar NaOH. Now added same vessel, same funnel. Funnel shaken vigorously and kept aside. Ethyl acetate layer in the funnel contains. That means 2 layers possible because this is aqueous NaOH. NaOH solution is aqueous NaOH only. Okay. Now what is the reaction of NaOH with this one? No reaction. Aniline no reaction because base only. It is not possible to break this bond. Very high temperature requirement. So that's why not possible normally. This is simple possible. Why? Acid base reaction. pH COOH plus NaOH acid base reaction of salt and water. soluble salt also, PHCO minus Na plus water. That's called soluble salt or water soluble salt. So that only transfer from the organic layer to aqueous layer of NaOH. Which compound transfer? Benzoic acid. So now this contains C6H5 COO minus and Na plus. And this contains remaining two called chlorobenzene and aniline. So ethyl acetate layer contains chlorobenzene and aniline. Option 4. Aqueous layer of base contains salt of sodium benzoate. Okay, so answer 4. Next, hydration energy of potassium chloride minus X minus Y kilojoule per mole respectively. Lattice energy of KCl is minus Z kilojoule per mole. Heat of solution is enthalpy of solution. Both are same only. Delta H solution is equal to lattice energy plus delta H hydration of ions. Lattice energy given as symbol given minus Z plus hydration energy of cation anion K plus Cl minus minus X minus Y or minus Z plus minus of X plus Y. Okay, but in lattice energy symbol important. What is symbol given? Lattice energy of KCl is minus Z. So we have to substitute plus Z minus Z. That's doubt here. Look here. KCl, K plus Cl minus dissociate to form K plus Cl minus. This is separation into their ions. First gaseous state and then into dissolved aqueous solution. This is combination. But during dissolution, KCl is not forming, it is dissolving, separating. That is why this direction lattice energy plus Le. This direction lattice energy minus Le. But this dissolution, that is why substitute this Z value not minus Z, substitute as a plus Z because it is nothing but separation, dissociation, positive value of Z. So, this value given in terms of minus Z means formation only, maybe not given formation only. That is amount of energy releasing 1 mole of ionic compound is formed from constituent gaseous state cations and anions. That is minus value. The same definition reverse. Amount of energy required to break 1 mole of ionic compound into its constituent ions of K plus and Cl minus of gaseous state is called plus lattice energy. That's why here use plus Z minus of X plus Y. So Z minus X plus Y, option 3. Okay. Next, kinetics question. A gives rise to B plus C gas. Okay. Time t0, I'll take p0. Time t, p0 minus x, x. Time infinity, complete take place to form p0 amount and p0 amount. But from the table it is given as p0 plus p0 2p0 is called P infinity. P0 is equal to P infinity by 2. And this value also given at time t. Pt. Pt is equal to P0 minus x plus x plus x. P0 plus x. Okay. X equal to Pt minus P0. Pt minus P0 value P infinity by 2. Okay. Substitute this value in the first order formula. K is equal to 1 by T ln P0 by P0 minus x. 1 by T ln P0 value P infinity by 2 by P0 minus x. P infinity by 2 minus x. X value is Pt minus by 2 is equal to P by 2 by minus plus. So 1 by 2 plus 1 by 2 P infinity minus Pt. 1 by T constant ln. So 1 by T 2 times of P0 because term denominator 2P is infinity minus of Pt. Option 3. Okay. So first to T 0, P0 0 0, P0 minus x x x, P infinity. At infinity no reactant, complete to product side. That is 2P0 equal P infinity. Substitute the value in the first order formula P0 by P0 minus x. So just substitute P0 value and x value. P is an optically active compound with molecular formula C6H12O. When P is treated with 2,4-DNP, it gives positive test. Means reacting with 2,4-DNP. 2,4-DNP common test for both aldehyde ketones. But presence of tolerance reagent P gives negative, means no aldehyde. So all ketones only. And require chiral, first important, optical active. No optical active, here active. Optical active, chiral. Here also active. But it's aldehyde. Gives tolerance test. So, this is aldehyde ion. This is ketone. But this is not active because both of them are methyls, no chiral. So direct answer only option 2 because as per condition 2,4-DNP test for the both aldehyde ketone, but P does not give test with tolerance, means it is not a aldehyde. So that's why option 3 not correct, option 2 only correct. Check the reaction. CH3 C double bond O, CH CH3 CH3 plus H2N NH 2,4-DNP. Loss of water. So that is not disturbed. Here only chirals remain same only. And C double N imine bond formation. That is called 2,4-DNP hydrazone. So positive test only. So option 2 only correct. Next, 56th one. Incorrect trend in the following radius. Bromine, potassium. Both are same period. Bromine, potassium. 4th period. Along the period, atomic size decreases. So correct one. Magnesium, aluminum, same period. Sodium, magnesium, aluminum. Along the period, radius decreases. Aluminum is small than magnesium, so it is not correct. Rubidium, cesium, same group. Rubidium less than cesium, correct one, because same group. Astatine, cesium, same period. Astatine is smaller than cesium. So 1, 3, 4 correct order, 2 not correct. Next, nucleophilic substitution. Aromatic SN reactions increase with electron withdrawing groups at ortho and para. So chlorine to OH, no substitution. Direct not possible because of resonance stability, very high temperature and pressure requirement. So first conversion is water not possible. 368, no, nearly 623. That is option A. That is 623. 4th condition. Next, 1 NO2, slightly less because 623. Slightly less means 443. Ortho para, 2 nitro groups, still less temperature, 368. 2. This is no need of temperature, just warming. Just warming with water, steam, because of all ortho para having nitro. That is why 1. So 4, 3, 2, 1. Option 3. Next, 58. Correct statement among the following is: the term standard state implies temperature is 0. No. Temperature not fixed, pressure only fixed. That is at any specified temperature. At any specified temperature. But pressure must be 1 bar. Standard state of pure gas, the pure gas at pressure 1 bar, temperature 273. So, this is correct but not correct. Delta H naught F 298 Kelvin is 0 for O. No, O is not element, not correct. Delta H naught 500 Kelvin 0 for O2, correct one. Because O2 is a standard element of molecular state. 4th only, because temperature is not constant, can take any temperature. O2 is a gas. Gas value equals 0. Next, 59. Liquid AB forms ideal solution. Pressure of pure liquids AB given. P0 A. P0A is equal to 350. P0B equal to 750. So B highly volatile because more vapor pressure. Okay, XA, XB, mole fractions in liquid state, YA, YB, mole fraction in the vapor phase. The relations are. So we can guess directly because AB low, A less volatile. Volatility, if we compare, A less than B, A slowly vaporize, B rapid vaporize. Slow vaporize means more amount liquid phase only present. That means mole fraction of A is high in the liquid phase, vapor less. That is why XA by XB, XA by XB is nothing but moles of A by moles of B, because mole fraction ratio equal to mole ratio. So liquid phase lo more number of A present. So X by X by Y. It is greater than YA by YB, because YA very small, YB high. That's why this relation expect from the given values. Okay. But how to check, how to prove this condition? So is the correct one. Now check. YA is equal to PT into, PA is equal to PT into YA. YA is equal to PA by PT or P0A by P0A chi A by PT. Same YB is equal to P0B chi B by PT. Take ratio, PT cancel. P0A by P0B into chi A by chi B. We do this ratio already, less than 1, because P0A by P0B is less than 1, because 350 by 750. Now take this side. Therefore, YA by YB all divided by XA by XB is equal to P0A by P0B. But this value is less than 1. That is why YA by YB is less than XA by XB. Okay. Next 60. X is number of acidic oxides. VO2, V2O3, CrO3, V2O5. Vanadium VO, VO2, V2O3, V2O5. Most basic, less basic, amphoteric. But actually here, if VO is 100% basic, these three compounds not completely basic, not completely acidic compounds. If V2O5 is called amphoteric, but same inside here, it is example of predominant acidic character. So predominant acidic character, most acidic, less basic, most acidic, less basic. So V2O5 is contains most acidic and less basic. So what is meaning of less basic means other present slightly more acidic. That means Here acidic product starts here, VO2. Small percentage starts. More percentage of acidic. Acidity increasing, basicity decreasing. That's why last salt is taken as amphoteric salt. But percentage wise, don't take 50-50. Amphoteric meaning is not 50-50. Any one may predominate. That is why acidic compound is more predominant in case of V2O5. But for textbook wise only, basic, less basic. Textbook is not given as these are acidic compounds. But suppose question given is amphoteric compounds, they are countable as amphoteric compounds because of less basic nature, contains some amount of acidic character. But to follow clearly statement textbook NCERT, amphoteric given, all this compound given as amphoteric given. These two compound not given as amphoteric compounds. Because, okay. So, acidic means complete acidity only. This is no acidity because the amphoteric, most acidic okay, but not complete acidic. We want complete acidic compound. Complete acidic means plus 6 plus 7 states. Plus 6 plus 7 state. This is plus 6 plus 7. Plus 6 and plus 7 oxidation states are 100% acidic only. Plus 2 state is called 100% basic compound. Okay. So, X value is equal to acidic, two compounds only. Chromium oxide, manganese oxide. Primary valency in the cobalt is Y. So, this is En. So, can write formula NH2 CH2. Simple like this. CO En thrice 2 times and SO4 taken 3 times. 2 cobalt to 2X plus 0 because En 0 minus 6 sulfates means minus 6. X equal to plus 3 is called primary valency. Oxidation state is called primary valency plus 3 states. That is called Y value. So, X plus Y is equal to 2 plus 3, 5. Okay. So, follow same textbook lines only. V2O5 is called amphoteric oxide but predominantly contains acidic character. Descending order of basicity of the following amines. Descending order of basicity. Basic nature, density of electrons, amines proportional to plus R effect. This is plus R effect. This minus R effect. Minus R decrease the basicity. This is aliphatic amino. Aromatic. Aliphatic amine is more basic than aromatic amines. So, these are aliphatic amines. Aliphatic law, secondary is more than primary. So, E more than D. Next, plus R effect, B. Next, parent, A. Next, minus R effect, C. EDBAC. Option 2. Next, 62. Just match the following with the primary secondary valency. Primary x minus 3, 0, x equal plus 3. Secondary 2 coordination number, 2 into 2, 4 plus 2, 6. 3, 6. So, correct only 3, 6. A1. Platinum x 0 minus 1 minus 1, minus 2, plus 2. Coordination 2, 3, 4. 2, 4, 4. Mercury 4 coordination. Mercury 1 x minus 4 x equal plus 3. 4 coordination 2. EDDA 6 only. Manganese plus 2 charge. 3. Because x minus 4 is equal to minus 2. X equal plus 2. EDDA charge value 4 minus 4. Okay, but this example, textbook example is important. Mercury is plus 1 state here. Normally, single mercury is not plus 1 state because single mercury does not exist as mercurous. Always dimeric form, Hg2 plus 2. Hg2 plus 2 is called mercurous. Single mercury is called mercuric, Hg plus 2. But textbook example, in which this example given as mercury plus 1 given, follow plus 1 only. But no confusion because no other choice here, only for this one only present. Then it must be plus 1 only. Next, solution of chloroform and acetone. Chloroform acetone means hydrogen bond formation. Negative deviation. Maximum boiling azeotrope. Three. Ethanol water opposite to positive deviation, hydrogen bond dissociation, minimum boiling azeotropes 1, benzene toluene ideal delta V 0, acetic acid benzene dimerize 2. 3142. Option 1. SO2, NO2 minus, N3 minus, hybridization atoms of central atom respectively. SO2 is sulfur divalent. That means 4 electrons take part in the bond formation. 4 electrons means sulfur must undergo excitation 3s2 3p4 into vacant d orbitals. Three s2 3p4 one electron exciting to 3d orbital. 2 sigma bonds. So these 2 sigma bonds. Lone pair remains same. sp2 hybridization. E2 pi bond, 1 pi bond pp, 1 pi bond dp, because p pi d pi bond, because d orbital. sp2. NO2 minus nitrogen 1 O minus single bond, 2 sigma bond, 1 pi bond, sp2 hybridization, direct, because no excitation here, direct sp2 hybridization. N3 minus 1 only. Follow formal charge. Minus 1 is the net charge. Because this is plus, this is minus 1. From formal charge values, you find out this get minus 1 plus 1. Sum is equal to net value minus 1. Okay. So nitrile forming 2 sigma bond, 2 pi bonds. sp hybrid. So both sp2, first two, last one sp hybrid. Like 65, number of unpaired electrons responsible for the paramagnetic behavior of complex spaces. Paramagnetic means unpaired electron requirement. Na? So FeCN6 minus 3, Fe3 plus. Strong ligand. Fe3 plus, strong ligand, 3d5. Pairing in the T2C. One unpaired is there, paramagnetic. Fe6, weak ligand. Weak ligand add paramagnetic only. D5 add paramagnetic because no pairing. Weak ligand. CO plus 3. 6. D6 means 4 unpaired electrons. MnCN6 plus 3. D4 strong ligand. D4 strong ligand. Follow Hund's rule. 1, 2, 3, 4. So 2 unpaired. So number of unpaired electrons. First one lo 1. 5. 4. 2. 1, 5, 4, 2 respectively. Option 1. Next, 66. Number of optically active products obtained from the complete ozonolysis of the given compound is. Complete ozonolysis of compound is. That means this is on ozonolysis, OO. This also OO. So, the last compound I think CH3 missing here. So, products equal to this compound, this one both same, 2 moles of acetaldehyde. Or if you take CH2 also not correct one because formaldehyde. So, CH3, CHO. Or you can take 1 mole aldehyde and 1 mole formaldehyde, acetaldehyde formaldehyde. Next, this is CHO, both same only. Center one, C, H3, CHO, CHOH, no chiral. Next, this same only, 2 moles. So, all products are not having chiral centers. So, no chiral carbon. That's why 0 error. Option 2. 67. Cis dichloro is more polar than bromine. Correct one, because carbon chlorine bond is more polar bond. Than carbon bromine due to high electronegativity. Boiling point of trans bromo is lower than cis. Correct one. Boiling point of trans less than cis, correct. But it is more polar than this compound, wrong, because here less polar. Dipole moment cis greater than trans, or polarity cancel. Mu 0, but here mu non-zero. So boiling point, okay, trans is low boiling point than cis. The reason is called less polar. Dipole attractions are very weak. But cis having moment, therefore force of attractions are strong in case of cis molecules. So high boiling point in case of cis molecules. Trans molecules 0 because low polarity. But trans is more polar than the cis, wrong. That's why second also wrong statement. So second wrong statement. First one correct. First one correct, second wrong. Option 1. Cis more polar than trans. Next, 68. Extra stability of half-filled subshell is due to. Half-filled subshell may be P or D due to exactly half-filled. Symmetrical distribution, correct one. Smaller Coulombic repulsions, correct one, because all of same directions, repulsions are less. Presence of electrons with the same spin in either wrong. Same spin correct, but they are not non-degenerate, they are degenerate orbitals. Both of them are degenerate orbitals having same energy. So C wrong. Large exchange energy. So that's why exchange of electron takes place from one orbital to another orbital. Correct one. Relatively small shielding effect of electrons by another. Correct one, because only one electron present, not two electrons. If two electrons present, it gives shielding effect on the second electron. But each orbital has only one electron only. That's a relatively smaller shielding effect of electrons by one electron. So also correct one. Relatively small shielding effect of electrons by one another. Right. So A, B, D, E, except C. A, B, D, option 2. Next, 69. So this was statement questions, so same model questions. Thallium plus 3 is a powerful oxidizing agent. Correct one, because unstable due to inert pair effect. thallium plus 3. Readily converting into thallium plus 1. 3 to 1 is called reduction. Therefore, oxidizing agent. Aluminum plus 3 does not get reduced easily. Correct one. Because it is already having stable configuration. Both aluminum and thallium very stable in solution. Wrong. Only aluminum stable. Thallium plus 1 stable than plus 3. Correct. Thallium plus 3, thallium plus 1 highly stable. Correct. So same question of previous also. A, B, C, D, E. C not correct. A, B, C, D, E. C not correct. Same answer. 2. Next. 1 molar aqueous solutions of copper nitrate, silver nitrate, mercurous nitrate, magnesium nitrate using inert electrodes. E0 value is also given. Statement 1. With increasing voltage, the sequence of deposition of metals on the electrode is. So, cations at cathode. Cations at cathode will deposit having more SRP. So, which is the more SRP value here? 0.8 is the highest. 0.8. So, silver highest SRP. Next, mercury 0.79. Next, copper 0.34. But magnesium not possible because the question given is aqueous solutions. There is a SHE present here. 0 volt. After 0, negative starts. That is the reason aqueous solutions negative ion SRP cannot be deposit. H2 deposit. Because at cathode H plus ions and Mg plus both present, but H plus is 0 volt, Mg plus 2 is minus value. Which is more value? 0 is more value. That is why water undergoes, H2 undergoes reduction to form H2 gas plus OH minus. Or 2H plus 2 electron equal to H2, but not magnesium. Okay, so increasing voltage sequence of deposition, first silver, mercury, copper. Correct. 1 correct. Statement 2, magnesium will not deposit. Correct one. But read complete statement. Will not deposit cathode. Correct one. Instead of that, oxygen gas evolved at cathode. Wrong. Because the gas is not oxygen, it is a hydrogen gas. That's why statement 2 false. 1 correct, 2 false. 1 correct, 2 false. Option 2. 71. Only liter buffer. I think 1 liter buffer. 1 liter buffer prepared by adding 0.1 mole each of ammonia and ammonium chloride. Change in pH after addition of ammonium chloride, 0.04 moles of HCl. First initial pH, next final pH. Initial pH means first take pOH value. pOH equal to pKb value 4.745 plus log of salt by how much salt? 0.01, 0.1. So 4.745. pH equal to 14 minus 4, 9.255. Okay, first pH. Next, final pH. Final pH is reaction. What is the reaction? NH4OH plus HCl combined to form NH4Cl. Already solution contains 0.1 mole, 0.1 mole. Now you are adding 0.05 moles. Limiting reagent. So 0.05 react to form 0.05 plus already present 0.1. So remaining value 0.05. This is 0.15. This mixture is called again buffer only. pOH equal to 4.745 plus log salt 0.15 by 0.05. Log 3 given 0.477. 4.745 plus 0.477. This is a change. Question is not about the value, change only. Change. 0.477 units changes. Therefore, 0.477 units changes. 10 dash minus 2, therefore 47.7. Nearly 48. 47.7 minus 2, nearly 48. 10 dash minus 2. Okay. Next one. Dumas method, 292 milligrams of organic compound release 50 ml nitrogen at experiment condition. So same model type. P1 V1 by T1 equal to P2 V2 by T2, because first you convert it to STP conditions. This is experiment conditions, STP conditions. Experiment condition 715 and aqueous tension was given. 715 subtract aqueous tension because we want pressure of dry gas only. Volume 50, temperature 300. P2 760. V2 find out. T2 273. Dumas method. Percentage of nitrogen equal to 28 by 22 400. Volume of nitrogen at STP by mass of compound into 100. Volume in ml because CG system. 28 by 22 400. Volume V2 find out. Substitute here. That is 700 into 50 into 273 by 300 into 760 into 100. Okay, that gives nearly 18%. Check once again. Mass of component W is the 0.292. 17.99 taken as 18%. Okay. Next, 73. Butane reacts with oxygen to produce carbon dioxide and water following equation given below. Butane plus 13/2, 4CO2, 5H2O. 174 kg butane, 320 kg O2. The volume of water formed in liters is. So stoichiometric problem only. C4H10 plus 17/2 O2 equal to 4 CO2, 5 water. We want water only. 1 mole, 6.5 moles, 5 moles as per the stoichiometry or equation. Given moles, 174 by butane 48 less than 58, 320 kilograms by 32. So 58 3 times 24. So 3000 moles. 1 4 zeros, 10,000 moles. Limiting reagent is, which was limiting reagent? 1 mole with 6.5 moles. 3 moles 6 times 18,000. But not there. 10. So this side. Limiting is called oxygen. 6.5 use 5. Then 1000 use, 10,000 use. How many? 5 by 6 into 6.5 into 10,000. 7692 moles into 18. 138.46. 138,461 grams. Gram equal milliliters. 138,461 milliliters. Liters 138 point liters. Point for this, 138 liters. Okay, so limiting is O2. With respect to O2, amount of water find out. Next, 74. Number of paramedic complexes in the following is. Cobalt ammonia strong ligand pairing takes place. So first one low. I did memorize. First one low. Complete pairing takes place in T2 level. So diametic. Second one low. Same strong ligand pairing takes place. Because cobalt plus low, all strong ligands, so up to OH minus ions. Mn weak ligand plus 3. Mn plus 3 means 3d4. 3d4 equal to normal 1, 2, 3, 4. Paramagnetic. MnCN6 plus 3. Same but strong ligand. Pairing takes place T2Z. 2 unpaired. Paramagnetic. Cobalt fluorine weak ligand. Cobalt weak ligand. That is number 5. Cobalt plus 3. 6. Normal 6 only. Normal 6. 1, 2, 3, 4, 5, 6. Paramagnetic. because weak ligand no pairing take place. Next strong ligand Fe3 plus T5. D5 pairing in the T2C. 1, 2, 3, 4, 5. One unpaired is there. Paramagnetic. So number of unpaired electrons, number of paramagnetic metal complexes, and number of same number of unpaired electrons. Same number of unpaired electrons. So para will select. This para with 4 electrons. This para with 2 electrons. This para with 4 electrons. This para with 1 electron. So paramagnetic and same number of unpaired electrons. So 4, 4, same number. That is called 2 species. Number 3 and number 5. Next, sequence of reaction. Find out total number of sp2 hybridized carbon atoms in the final compound D. First compound is loss of chlorine with oxygen, dichlorination. PHCl, gem dichloro compound. Next, dehydro halogenation with 2 moles first. 2 moles of 2 equivalents of Na, NH2 by ammonia gives alkyne. Next, acidic H present. One mole of NaNH2 replaces hydrogen to form salt. pH C triple bond C minus Na plus. Next, acidify. Again add H plus, acidify into alkyne. Next, E compound C, E compound B. C with HBO, anti-Marconi, H plus OH minus. But here one exception is there. This is attached triple bond. OH go to this side because of more stable carbon. Exception case, this side OH, because boron go to less sterically hindered side. That is next undergoes oxidation to form OH group. So here boron attacking because this is called planar ring. That's why this is attaching. Sorry, follow mechanism wise. So follow mechanism wise here. HBO first to BH3. Boron part go to less sterically hindered side. So here comparison of hydrogen and phenyl. This is less steric hindrance. PHCH double bond CHBH2. Because this carbon is called less steric hindrance. Next to OH. Oxidation takes place with H2O2. PHCH double bond CHOH. Now it undergoes tautomerism to form aldehyde. PHCH2 CH double bond O. This pH lo all sp2 only because benzene cycle. This is sp2 also. 6 plus 1. 7 atoms are sp2. Because terminal alkyne always gives aldehyde in HBO reaction because the terminal side less sterically hindrance. So boron go that side, not phenyl side. If it is present as non-terminal, gives ketone. Okay. So that is the reaction, but question is given about only number of sp2 carbon atoms. So not compound. Compound aldehyde only, that is called terminal compound, terminal alkyne converted to aldehyde compound. Aldehyde is sp2 or ketones sp2 only. 6 fixed plus 1 extra. 6 plus 1, 7. sp2 carbon atoms. Suppose it is given as sp2 hybridized atoms, then 8 answer. Why? If O also sp2 hybridization. But question is only carbon atoms only given. So carbon means benzene cycle carbon atom. So here 1 carbon atom, or 7 carbon atoms. That's 7. Just only sp2 hybridization means plus O also extra. That is 7 plus 1, 8 O. But now 7 only answer correct. Because of carbon atoms only sp2 hybridization asking question 7. Okay. Thank you.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.